The committee have 5 minutes each to ask questions. Your written testimony will be included in the record of the hearing. I now recognize our first witness, Dr. Kiesling, for 5 minutes.
Thank you. Mr. Bouchon, Mr. Lagebauer, distinguished committee members, I thank you for the opportunity to be here. You've done a good job of outlining both the problem and potential solutions and pointed to one of the major problems that we face in not only lack of funding but lack of continuity in funding to do the research we need to do. One other thing I'd point out is not just the loss of lives and the human suffering, but the anxiety that comes with severe events like tornadoes and hurricanes. And I will speak primarily on storm shelters or safe rooms because that's where I've spent most of my career working. And secondly, I think it addresses this last problem of anxiety and human suffering effectively. I have been part of the wind engineering program at Texas Tech since 1970 when a F5 tornado impacted Lubbock. I was chairman of the civil engineering department at that time. You can help make my day by telling me I don't look old enough to have done that, but I don't want you to lie. With your support, we've developed a world-class program at Texas Tech, unparalleled facilities that I have included a picture of some of in the report, a unique doctoral program in wind science and engineering, and we've turned out about 20 doctoral students or graduates there, and they're taking prominent places in the professional community. And today we have very good weather forecasting that gives information on locations and paths of tornadoes and hurricanes, but we still have to deal with the effects of severe winds. And even the advice given the public we found in the last 2 weeks in Oklahoma leaves much to be desired. In fact, it's inaccurate and dangerous, some of the advice that's being given. So not only do we need to do the good work such as forecasting has done, but need to convey a consistent message to the public as to how do you react and how do you respond to disasters. A focused approach to research and development and implementation is needed to reduce impact of windstorms on urban society. Many specific areas could be mentioned: testing facilities, a repository for windstorm damage documentation, and that's in progress, development of computational wind engineering tools, implementation of known research into standards and codes, and others will speak to that, development of manpower to pursue meaningful research and professional practice. And then educational programs that convey sound, consistent guidance to the people as to how they react and respond to extreme events, extreme wind events. Property damage can surely be abated by improved building codes and by their enforcement. We have a tremendous problem in lack of enforcement because that's done largely at the local level, and there are many disconnects that occur between the agencies and the researchers that generate good research and what happens in the field. And education, I think, is the best way to address that. We have, particularly in the storm shelter area, available standards and guidelines. We have an industry association, the National Storm Shelter Association. We have a SEAL program that recognizes those storm shelters that comply with the standards. We have all types of shelters available today that meet these standards and guidelines and provide near absolute occupant protection from extreme winds. Yes, even an EF5, despite some of the information that has been given, particularly in the last couple of weeks in Oklahoma. some of the advice given has been deadly and wrong. There are many characteristics of the Hazard Mitigation Grant Program, and Ms. Johnson, you mentioned that. It's an excellent program that does a lot of good things. The downside of it is that the funding that's generated is post-disaster. So it sometimes is 4 or 5 years. We're just now finishing some projects that were funded with the Hazard Mitigation Program, with funding going out of Hurricane Ike that occurred 5 years ago. So it takes time, and I think it's important that we have, say, pre-disaster mitigation grants of some type and sizable ones that can do preparation for disasters, not respond to them. I don't understand why the pre-disaster mitigation grant program was discontinued. And I'm not saying that we need that, but we need something like that that allows us to prepare in advance. There's been a lot of talk about shelters being mandatory. I believe that the states, such as Alabama, has set a good example, and that storm shelters for schools should be made mandatory by states that have the serious problem in new buildings, and much can be done to improve existing buildings in that regard. I believe that mandatory laws should also, or shelters should also be for multifamily residential housing units, vulnerable populations such as daycare centers, retirement villages, and so forth, nursing homes, mobile home parks, and apartments. I think it should not be mandatory for privately owned single-family and multifamily residences, though incentives of some type would certainly be appropriate. So my recommended action would simply be that you've identified the agencies, the NIST, FEMA, NOAA, NSF. All are experienced in administering large-scale programs, and they work well together, I think. We have capable professional personnel that conduct research if they have adequate funding to do so. And I think if you look at particularly at the programs that have been funded, the earthquake program and the prediction program in the weather area, you will see that we have unprecedented return on investment in those programs, and I would encourage Congress to make funding available to make similar investments in the area of mitigating the wind disaster. Thank you.
Thank you. I now recognize our second witness, Ms. Ballen, for 5 minutes.
Thank you for the opportunity to testify today. My name is Debra Ballen, and I am with the Insurance Institute for Business and Home Safety, a 501c3 organization wholly supported by the property insurance and reinsurance industries and dedicated to mitigation research and communications. As a research organization focusing on mitigation, IBHS has long been supportive of the NWRP. We provided testimony during hearings that led to its initial authorization, as well as the effort to reauthorize the program in 2008, and we have worked in partnership on a number of projects with all of the NWRP agencies. We are pleased to be here today, and we thank you for your interest in this important matter. Given the broad geographic threat of windstorms, the percentage of our population at risk, the frequency of events, and the tremendous toll taken, the federal investment in wind-related research is much less than it should be. That said, we are not negative on a multi-hazard approach. A coordinated, well-funded research program as embodied in NWRP is needed to pull together scientific information about wind hazards, wind engineering expertise that defines the connection between storm characteristics and loads imposed on buildings, structural engineering expertise that develops efficient systems to handle these loads in new and existing buildings, and national coordinated efforts to promote mitigation. We believe that IBHS can play an important role in these initiatives. The centerpiece of our research program is our unique world-class research center. Using a 105-fan array to simulate wind, as well as full-size residential and commercial test specimens and other specialized equipment, IBHS can recreate a variety of highly realistic natural disasters, involving wind alone, wind plus rain, wind plus fire, and wind plus hail. I would like to take a moment to show you how research and related communications contribute to our understanding of the destructive power of wind and the benefits of mitigation. You will see the power of wind in a video from the first public demonstration that we conducted at the Research Center in the fall of 2010. We subjected 2 wood frame houses to a highly realistic storm, as has occurred in North Texas and the Midwest. Although they look the same from the outside, the home on the left was built using a code as it exists in central Illinois, while the home on the right was built to a higher IBH standard. I should add that the winds you are going to see were not tornadic. So here is a very short video of that test. You can see just how quickly and how completely the home on the left was destroyed. And as you think about the loss of life and property, had this been a real event with people inside the home that was destroyed, you can also understand the importance of research as a complement to communications in order to get people to pay attention, change their attitudes, and ultimately demand safer and stronger building. It is much better to learn this lesson from the IBH test chamber than from places like Moore, Oklahoma, and Miami, Florida. Along with stronger, safer building, we believe that mitigation leads to a stronger, safer insurance system. Among the insurance-related benefits of mitigation are a reduction in the frequency and severity of weather-related claims, a downward shift in the loss exceedance curve, better management of losses in rare but severe events, more efficient capital deployment, healthier private insurance markets, and less stress on residual markets. The property insurance industry's research priorities for wind mitigation are directly in line with policyholder interests. Less physical destruction, less economic loss, less societal displacement, fewer injuries and deaths. Breaking the cycle of destruction so that residential and commercial structures do not have to be put together again and again will benefit building owners, occupants, communities, and also insurers. In closing, I thank you for the opportunity to offer our comments on the critical role of mitigation research and the importance of NWRP reauthorization. We urge you to move forward on this important legislation that will help to harness advancements in windstorm science and engineering in order to improve our nation's safety, sustainability, and resilience.
Thank you very much for your testimony. I now recognize our final witness, Dr. Prevatt, for 5 minutes.
Chairman Bouchon, Chairman Massey, and honorable subcommittee members, my name is David Prevatt. I am here to advocate on behalf of the American people for the creation of a wind hazard resilient communities within the next 10 years. I believe the reason we don't have this already is that no one has been bold enough or committed enough to demand it. I wish to add the support of the American Society of Civil Engineers and the American Association for Wind Engineering and my own support for H.R. 1786. These organizations have been working for the past 10 years since Congressman Randy Nogabawa of Texas first proposed this legislation. We also support the transfer of leadership to the National Institute of Standards and Technology. Since Professor Fujita first published his Fujita scale in 1971 and his report on the Lubbock tornado, our populations in the tornado alley has grown 50%. What does that mean? We have more schools, we have more hospitals, commercial spaces, and certainly a lot more houses. It's not complicated. There are today more objects in harm's way than there were before. Also, since 1970s as well, NOAA and the National Severe Storms Laboratory has invested heavily in weather infrastructure, over $167 million over the last 10 years, in better research to predict unstable weather, in providing warnings of tornadoes, in more equipment, forecasting products. The public is aware of this and confident in its use. and private sector has stepped up to mine it. We can get forecasting information on our smartphones. It's not complicated. Longer lead times before tornado strikes reduce loss of life. In parallel, the 1970 Texas Tech University wind engineering faculty, they initiated the first building damage studies after the Lubbock tornado, documented problems with houses, how they are made. Modern houses still have those problems. Houses have smaller nails, fewer nails than they once were in the 1940s. Connections are inadequate. They cannot resist tornado loads. Houses are insufficiently anchored to the foundations and they rack very easily. There are no vertical load paths in the houses built in Tornado Alley, and I can attest I was there in Moore, Oklahoma 2 weeks ago. It's not complicated. The result is more houses, more poorly built houses, and more property lost and disruption of our communities. Tornadoes now, damage has increased 2.5 times since the 1970 Lubbock tornado. So my message today is not complicated. It's simply to tell our representatives that the people of the United States want to live in tornado-resilient communities. They also deserve to live there without fear. A tornado-resilient community is one where all schools have shelters, or at least safer spaces that afford some protection to our children. That our hospitals and emergency buildings are all hardened against tornadoes, wind hazards, and earthquakes. That our houses are built so that fewer will be completely destroyed, destroying the lives, and some will be repairable after a tornado. Civil infrastructure are designed for tornadoes, and that the private sector has the research backing to work to economically develop affordable and weather-resilient houses. Really, it's not complicated. The wind engineering and structural engineering communities stand ready to begin this work. We have been ready for 10 years. And with your support, we can begin this task to provide for our people. To get there, please support H.R. 1786, authorize its funding, and sustain support for the wind engineering and structural engineering communities for our houses. Let's mobilize communities, leaders to upgrade their building codes and include a vertical load path provisions in all buildings, Support our research community to work with innovative private sector companies to design buildings and build resilient and sustainable 21st century houses. It can be done. Advance the wind and structural engineering research program. Support your faculty that will provide these solutions to these existing problems. Honorable members, it really isn't complicated. Thank you.
Thank you very much. I want to thank all the witnesses for your testimony. It's a fascinating subject. I want to remind the members that the committee rules limit questioning to 5 minutes. The chair will at this point open the round of questions. I recognize myself for 5 minutes. Ms. Ballen and Dr. Prevatt, initially, what are the stepping stones that are preventing us from building better homes? I mean, what's the rate limiting steps? Why even with all the information we have out there, why don't we do it?
Well, we've actually developed a strategic plan at IBHS that I think responds to your question, and that is, first, we need to get people to pay attention. We have the research capabilities. These fine universities, work that groups like ours done, provide the technical answers, but we need people to understand them. And the video that you saw, I think, is an example of getting people to pay attention. That video has actually been on the Today Show. It's been on the Weather Channel. People have seen that and begun to think about, gee, how do I make that not happen? So the next step is getting them to change their minds and getting them to value that stronger roof instead of a granite countertop. And once individuals are making those choices, we as a society need to rise up and really demand a demand to be in a community with a better building code, or demand that the Congress enacts these types of legislation. I think a lot of people just they haven't gotten that first step, so they can't get to the second step and the third step, and that's at least our one perspective on that. Dr. Prevatt?
What I would add to that is we still lack the knowledge of designing buildings for tornadoes. There has been a dearth of research in wind engineering that supported the faculty working on wind engineering matters. We had the zenith in the 1980s, and since that time there just has not been the research there. Currently, we're trying to understand how the tornado loads interact on a particular building, how the load paths have to be improved in order to do that. So part of the problem is not only do people need to be initiated to want to change, we have to provide an opportunity and knowledge of how they can change.
Thank you. I can tell you I was in healthcare before, and there's a powerful motivating factor for people, and it's called denial. And it's a very difficult thing to overcome when people see what's the statistical chance of their home being hit, and convincing them that they need to have that home built with higher standards. It's a very, very difficult thing to overcome, as well as messaging why that is the case. Dr. Kiesling, this is my own personal question. Is there research out there on not only telling us where tornadoes are and where they're going, but how to divert them away from urban centers?
I think the first part of that question the answer is yes. Certainly the people are doing an excellent job of predicting the path and where the tornadoes are. I don't see any hope of diverting, though we occasionally hear from people who have proposals for that. In the first place, we don't know where they're going to occur far enough in advance. And secondly, there's a tremendous amount of energy there that has to be dealt with in trying to divert them. So I frankly, personally do not have much hope for that.
Or dissipate them, for example, dissipate the energy or anything like that.
Hopefully it can work. I have to depend upon, I guess, the next generation to come up with solutions there, because I simply do not see how we can dissipate or divert tornadoes.
Okay. Is there describe the difference in research between straight line winds and tornadic winds? Is there a big difference there?
Well, straight line winds generally, we know what pressures they exert on buildings, and they're pretty predictable. But in a tornado or a hurricane, the variations are great, and I think we need to know a lot more about not only the intensity, but the variation and the characteristics of extreme winds, so that we can better deal with them. And we're making progress, but again, it's a long, slow process and requires manpower that is hard to come by.
You have a comment, Doctor?
I would add that in tornadoes as well, we have something that we don't understand, which is a vertical suction below the vortex. And that has never been, understood in terms of how it reacts or interacts with the winds that are swinging into the tornado.
Thank you very much. My time is about to expire, so I'll now recognize Ms. Wilson for her line of questioning.
Thank you. In her testimony, Ms. Ballen states that wind hazard research has been underfunded for decades. The other witnesses also express a similar sentiment in their testimonies. All of you indicate that NWERP has never been implemented in any meaningful way because of lack of resources. What opportunities are we missing by not providing the program with, as Dr. Kiesling puts, a reliable, sustained source of funding for maturation and expansion?
I think we just have to look at the earthquake engineering program and see what benefits we have gained from that. We're talking about something that has been funding to the level of, millions of dollars per year. literally all of the wind engineering research over the last 10 years in the top wind engineering schools amounts to about $1 million per year. We're talking about, and I have seen it, Joplin, Missouri, Tuscaloosa, and Moore, Oklahoma. We're talking about $2 billion, $3 billion, and $5 billion. Those are the numbers, and we simply are not addressing them. What has happened over the time, unfortunately, is there has been attrition of wind engineering faculty. Structural engineering faculty no longer study how to make houses stronger. They're onto, commercial structures and so on. And these are the areas where we have the most damage, the most dollars lost, and the most lives affected.
I agree certainly with everything that Dr. Prevatt just said. I think our feeling is that if there were more money that were in this program, or money in this program, since there really hasn't been money in this program, we've identified in a broad way the areas where we think we could really lead to progress. And the first is enhanced understanding of the events themselves, and different issues in terms of understanding tornadoes and understanding hurricanes, but certainly it starts with the science and the meteorology of that. The second is understanding the connections between those events and the built environment. We're doing some of that at the IBHS Research Center, but certainly more could be done through enhanced funding through NWERP of universities and others. We recreate the nature, and then we see how nature reacts to the built environment, homes and small businesses. The third area is identifying those mitigation measures that actually work. A tornado-proof home, or even in the area of hurricanes, where we know a lot more. There's still a lot more to be learned about how to make those structures better able to sustain nature. And the final thing would be making sure that the tests that our products and standards are based on really do accurately reflect the real world. What we saw in the auto safety arena was that everyone could build a car that withstood the first nits of tests because they knew exactly what they needed to build to, and that didn't necessarily mean it was safe in the real world. And so we need to develop testing standards that actually do reflect what we learned from the first side in terms of the real-world weather events. As far as the funding levels are concerned, as you identified in your opening statement, whatever the level is, and more is obviously better from the perspective, I think, of all of the panelists that are here. But you also identified that the static funding is a problem. If the idea of the program is some of these are short, some of these are medium, some of these are long-term events, if you fund it sort of at the same level throughout the 3-year period or whatever the period is, you get everything started and then you can't identify anything new in the second and third year. So we certainly would recommend at least modest upticks as you go forward so that, we can make sure that we can start what we finish, but also start other things that are identified in the early years of the program.
Dr. Kiesling, you have any response?
Sorry, what was the question? Did you ask me if I needed to add anything?
Do you want to add anything?
Well,
the lack of funding.
I think, again, not only the level of funding, but the continuity is a problem because particularly with young faculty, because young faculty are under tremendous pressure to produce research, to generate funding, to publish, and if they have areas where that funding is more readily available and dependable, then they're going to go to those areas. So it's very difficult for us to recruit young faculty into wind engineering, for example, because of the lack of our continuity of funding.
Thank you.
Chair now recognizes Mr. Schweikert for his questioning.
Mr. Chairman, I'd like to yield to the sponsor of the bill, Mr. Nagelbauer.
And I appreciate you, gentlemen. I think one of the things that we want to happen here, and it's been alluded to by the witnesses, is getting people to build buildings that will mitigate some of the potential damage and loss of life. And I think one of the misnomers out there is that you have to build Fort Knox, and so that the cost of building that, is not economic because of the probability of that event happening versus the cost of doing it. And so one of the things I think I'm very big on is using the carrot, rather than the stick. And so I have a couple of questions. One of those, do you see within, for example, many of these losses of property were insured losses. And so obviously the insurance industry has a huge interest in this issue. Two things. Do you see them recognizing a difference in homes or buildings built to different standards so that there's incentive for homeowners or people that are building a building to spend the extra dollars to do that? So that would be my first question.
Let me take that one since I know a little bit about that issue. We look at property mitigation in two ways. One are building codes, and one are efforts to go above building codes. Building codes, as much as we support them, are really intended for life safety as opposed to property protection. And so while obviously a code-built home is better in many ways, if the issue is property protection, I think that's not necessarily what an individual insurer is likely to consider the best possible. IBHS has developed a voluntary standard. It's called Fortified Home or Fortified for Safer Living, and does go above code. It's hazard specific. So we try to identify the types of building construction techniques that will help for specific hazards. Again, every insurance company does make its own decisions, but several states have recognized Fortified and requiring insurance companies to do that in their filings. So we do have a little bit of a track record in Mississippi, Alabama, Louisiana, South Carolina, and we are seeing that companies are, in fact, individually making decisions in terms of filing. That said, I want to emphasize that the types of things that are in Fortified are not unaffordable. They're relatively low-cost improvements that a homeowner can make, talking about a couple of $1,000s generally, particularly in an area that already has a code. One of our partners in terms of Fortified for Safer Building is Habitat for Humanity. They are actually the largest builder in this country at this point in time. And we have partnered with Habitat on a number of fortified homes in hurricane-prone areas and in other areas. And so if we can get those fortified standards into a Habitat home, you know that those are not unaffordable standards. It's a question of sort of being there at the time when decisions are being made. To say to someone that has a roof on a home, this is not a good roof, you need to take this roof off and put a whole nother roof on, is a very expensive proposition. But if you are at the point where a homeowner is replacing a roof or needs to replace a roof because the first roof has blown off, it doesn't cost that much more to build to a fortified standard.
And so I think one of the things that another theme of this particular legislation, but I think a theme that you hear a number of the people up here talking about is, dissemination of that information and coordination of that information. And so, for example, this research, for example, do you sit down with, say, industry participants, to say the national home builders, for example, and share, this information and introduce a dialogue with them to make sure that they are being made aware of this?
We certainly have started that. They started out rather negative and skeptical of IBHS and our capabilities and our mitigation messages, but we've invited them all to our research center. They see that $40 million facility. They see that fan capability, and they realize that we are very serious about doing the research and doing the communications, and that has led to a much more constructive dialogue. There are a number of organizations that we have had long-standing, very positive relationships with, and I should mention the ASE is probably one of our strongest partners here in Washington and at the state level, and certainly at the technical level as well. They have visited our research center. The architects are another group that we're trying to encourage young architects and architectural schools to incorporate stronger building into their curricula. So we are reaching out to a number of organizations. Our companies reach out to their policyholders. We try to leverage those relationships to try to get the word out, and the social media, which of course is huge in all areas and is huge after disasters. We're trying to make that part of the mitigation movement as well.
Thank you. Thank you, gentlemen, for yielding.
I now recognize Ms. Johnson for her line of questioning. 5 minutes.
Thank you very much. Just as a follow-up to the course of questioning, I can't forget the image of seeing the one lone house that remained standing during Hurricane Ike in Galveston. Only to think, how did it survive all out there alone? To find later that the entire neighborhood was devastated and that house survived. And it was because they had used the type of materials that would resist many winds. How do we, I just heard your comments from the standpoint of encouraging architects and all, but it seems to me that local ordinances, when permission is gotten for building, has to be involved. How do we do that without making it seem that this is big government trying to boss everybody? But I should think that insurance companies should be very interested in having resilience in the building, as well as governments. We've, with the ability of our satellite system to predict, we've gone a long ways in saving lives, but we haven't done nearly as well in saving property. And that is a major concern in an economy like today. How do you see that responsibility fitting where, and what can we do?
Okay. Representative Johnson, one thing I would tell you about that one building that you saw in Ike, I saw one building or one neighborhood in Moore, Oklahoma that had hurricane ties, something that actually would hold the roof down to the wall. Just one out of thousands and thousands that we looked at. Essentially, we have to do a better argument to convince individuals, as Ms. Ballen said, that this is something that they ought to think about instead of that granite countertop. Let's look back at ourselves 100 years ago. Our large cities, Chicago, New York, San Francisco, we all faced a fire considerations. Blocks and blocks were burning down. It was at that time that those city leaders, legislators, politicians, and the public got together and said, enough is enough. If Chicago is going to survive, we're going to have to, all pull in one direction, and that's what we did. And we can do it again. We have the ability to do it again. I think right now the public is generally fearful of tornadoes, fearful of the wind hazard, and they believe we don't have the talent to do it. I think we've put a man on the moon. We could pretty much keep a roof on a house.
Thank you.
I certainly agree with that statement. We are very strong supporters of building codes. And about a year ago, we did a little study. We called it Rating the States, and we looked at the building code regimes from Texas to Maine in the hurricane-prone, the coastal states, on a 0 to 100 scale. The scores ranged from 4 to 95. So there was quite a range. And I will tell you that as a public communications vehicle, a lot of people may not know what a building code is, but they know that it's good to have a high score and it's bad to have a low score. And that really has started a dialogue. And the most positive responses that we've gotten from the media certainly have been in those states with the low scores about how they can do better. One state that was not at the bottom was in the middle, but actually passed a bill this year, Maryland, that specifically addressed an issue that we had identified in those states. So it's a way of making building codes understandable to people. So again, they begin to demand that they want to be, we would say, ideally in a state. We support statewide mandatory building codes. It's much easier for enforcement. It's much more consistent. But there are some states where that hasn't happened, and Texas certainly is one of them. At a minimum, at the local level, there ought to be strong ordinances in effect.
Any other witness comment? Thank you, Mr. Chairman. I yield back.
Thank you. I now recognize Mr. Lipinski for 5 minutes.
Thank you, Mr. Chairman. In his testimony, Dr. Kiesling calls for economic, social, and behavioral studies to understand the implementation of research results like stronger building codes. I think this is something very important that we have to use the lessons from social science to ensure that the other lessons that we are learning from research get implemented. Can Dr. Kiesling and other witnesses expand upon that and where exactly they see the importance?
Well, I think implementation is a serious problem in many areas. I would back up a little bit and say that in terms of improved building codes, we can do a lot of good by simply meeting existing building codes. They're not, say, effectively enforced or inspected. But if we increased the design wind load only a small amount, we would save a lot of property, because even in a tornado, most of the damage is done at wind speeds, say in the 100 to 125 mile per hour wind. And if we design for a little bit more than we do, 90 or 100 mile per hour winds, that would save a lot of the structures that are currently being destroyed. I don't know what the answers are to implementation, but I see it as a serious, serious problem, not only in enforcing building codes, but it haunts me that I hear reports of traffic deaths in our city, and in many instances that people were killed in rollover accidents without wearing their seat belts. So they're sitting on property they already own that can be very effective in saving lives. And so it should not surprise us, I think, that we have problems in enforcing building codes and motivating people to do a better job of construction. I don't know the answers, but I think we need to involve maybe social sciences and disciplines that we have not effectively engaged before to see how do we implement what we already know. But there's much more to be learned. I don't say we have all the answers. We need to learn much more, but we also need to do a better job of using what we already have.
We are hoping actually to gather social scientists at our research center this December so that we can really begin to explore that in more detail. To the extent we've sort of sketched out the way we think about this issue, we think it's first a question of sort of getting the hearts and minds of people, getting them to really sort of want this, and we talked about that a little bit before in terms of one of the answers to the previous questions. The second is providing the adequate incentives. That's for both individuals and for states. An example of how that might work at the state level is the State Building Code Incentive Act that also has been introduced in this Congress, provides additional funding for states that do the right thing in terms of enacting strong building codes. That's a financial incentive. There could be other incentives for individuals. And finally, understanding the politics of this. We talked about the builders. You know, we have to make this a win-win proposition and make the market really want this to happen for us to sort of address those social science issues.
I might add that NOAA and the NSF, National Science Foundation, last year, they organized a pretty comprehensive workshop called Weather Ready Nation, in which they brought together the physical scientists and engineers with the social scientists to actually discuss the issues of weather, acknowledging that, yes, forecasting has got us so far, and yes, we are better at it, but the property damage. So the move has been started. There is a report which, if you would like, I can provide that link to you, in which we are now working with social scientists. I was on a rapid NSF project in Moore, Oklahoma, and we did involve Mississippi State social scientists and social scientists from the University of Alabama, as well as ourselves, engineers in other universities.
Thank you. Yeah, I'd like to take a look at that. I think it's something that we oftentimes overlook. I think in legislation here, we should make sure in NWERP that we include the social sciences, because you can do all the research that you want to know how to mitigate damage to property, threats to human life, if no one is implementing those. And we don't know, as Ms. Ballen said, we're not sure about the incentives of how to get people to actually take that into account. Then we just have research sitting on a shelf that's not doing anyone any good. So I think that's something important that we have to make sure that we are considering here in providing at the federal level. I'll yield back. Thank you.
Thank you. I now recognize Ms. Esty for 5 minutes.
Thank you, Mr. Chairman. As a quick follow-up to this, Mr. Lipinski's discussion, for Ms. Ballen, in looking at incentives, is the insurance industry offering lower premiums to those who have retrofitted or, say, hurricane ties? I mean, what sort of incentives is the marketplace providing? Because we know, for example, the tax credits do not seem to be terribly effective right now. So I'm wondering what's being done on the private side.
I always do stress that individual companies make their own decisions. But that said, IBHS developed a Code Plus technical standard called Fortified. We know that those technical standards work, and the program includes an inspection and designation process so that we know that the homes that were built to those standards, supposedly built to those standards, really are built to those standards. Many individual companies are providing discounts for fortified homes, and that's also been required in rate filings in some states. But it's not enough to say, if a homeowner says or a builder says that they've built to that standard, it is. It's got to be inspected. It's got to be verified.
Thank you. And a further follow-up, living in Connecticut, where we experienced a number of storms over the last few years, we have great concern about resilience, about the lifelines, utilities, infrastructure. So if any of the three of you can talk a little bit about what is being done on the research side on these critical issues where you can't have rebuilding, you can't even get access to people, you can't get them back online, and what we ought to be looking at in that department.
I think that is the entire direction of the Engineering School of Sustainable Infrastructure and Environment at the University of Florida. That's our entire mission. It is in several universities, resilience and sustainability are the hallmarks of what we're doing in civil engineering. Before we get to a sustainable society, we first of all have to get a resilient one that is more robust, and the research sometimes is fundamental to this. We do need to better understand the loads. We do need to better understand the structural properties of the buildings, the infrastructure, the utilities, what have you. But, I think we really just need to decide. We really do need just to decide that we want to live in a sustainable society, and we can do it. Yes, it'll cost some money, it'll cost some time, but I guarantee you, if you put engineers and scientists, social scientists as well, on this case, we can do this in 10 years. It takes, just that bold vision to go after it.
Well, I know some of the work, say, that Frances Cairncross has done looking at multiple ways to address climate change issues, and particularly with our populations being increasingly concentrated on the coasts. We are seeing, whatever it's attributable to, we are certainly seeing an increase in more severe weather. So I think it is going to be extremely important that we take this resilience line of research quite seriously and address it as an extremely high priority, as we are extremely energy dependent for everything that we do. If we do not harden our systems, we've been looking at cybersecurity, but we also just need to look at natural weather ability to bring down whole cities. And I'm quite concerned that we not forget how critical that is. Just look what happened in Staten Island, look what happened in New York. And we do need to be emphasizing retrofitting, not just new standards, but what are we going to do with major cities that need to be retrofitted for the utility side? Thanks very much. I yield back the balance of my time.
Thank you. I now ask unanimous consent to recognize a member of the full committee for questioning. there's no objection, then the chair now recognizes Mr. Nagelbauer for 5 minutes.
Thank you, Mr. Chairman. And I'd also like to return the favor and yield a little of my time to Mr. Swackert from Arizona.
Oh, thank you. I didn't know if I should object there, and if I put me back in, and then I could yield. Thank you, Mr. Chairman. It's Ms. Ballen? Ballen. Actually, Elizabeth was hitting a point that I wanted to go to. We all live in a world where how many of us right now will go out and buy a Volvo over, is it a Corvair? Any of us are old enough to remember a Corvair, unsafe at any speed. But the fact of the matter, when you're buying a car today, are we also looking at the consumer reports and saying, hey, this is safe, my insurance is cheaper? There is a price differential there driven by the insurance industry that actually changes our purchasing behavior. Why isn't that also the decision for those of us in purchasing residential real estate, is our price differential and our cost of insurance?
That's an excellent question, and one we ask ourselves every single day. Our peer organization is the Insurance Institute for Highway Safety, and they showed the way how research and communications lead to safer cars and people wanting them, and then you have enough people with these cars that you really begin to see the difference in the losses, and insurance companies respond to that.
Well, but I understand, for public buildings and schools and those things, particularly those with some federal resources in them, we have a voice there. But if I'm out buying a residential property or getting ready to refit or remodel, and how many of us have bought a house and we will fixate on small margins on the interest rate between one lender and another? But if there's actual price differentials understood in the market between, I did these types of tie downs on my roof and this house doesn't have these sorts of tie downs, so I'm going to pay this sort of premium. Isn't that the ultimate solution here?
That is the ultimate solution. The market is the ultimate solution. It would be benefited by the kind of research that we're talking about, but ultimately people need to want that. Now, I think that the impediments
the world works on incentives and disincentives, so they want it, they just need to understand, there's a price difference.
Yes, and the building industry is much more complicated than the automobile industry. There are thousands of builders out there versus 5 or 6 or 7 car companies. The guys that do it are every roofer.
And only because my undergrad is in real estate and my master's focuses on the finance. The real estate world is the life I grew up in. It's not the builders. It's the consumer. And if you told me, if I came to you right now and said, hey, you buy this house because of the way attributes, you pay this interest rate, but if I bought this one, I paid this interest rate, we'd all scream and go running to this one. Why is it not the same in interest or in insurance? And, Mr. Chairman, I'd like to yield to Mr. Nagelbauer because I know he had a little bit more on this.
Okay.
Thank you, gentlemen. Dr. Kiesling, one of the things that you mentioned a while ago is that the winds of a tornado are much different than just a gust, vertical wind. So, and there's different categories of events, all the way from, I guess, an F0 to F5, and so there's probably, in this particular point in time, the F5 is just, we don't have the technology, to on an economic basis to protect a home from an F5 storm, probably. So then if we go just to the mitigation of life over property, saying that the house doesn't make it, but there are things that you've done and worked on that of various degrees that are fairly affordable inside that home of fortification. Could you just kind of cover a little bit of what are some practical things that could be done in the homes, both retrofit and in new construction?
Well, thank you for asking. I think for early on, we more or less adopted the approach that it's very expensive to take a home of the type that we build today and design it to resist the worst case tornado. You can certainly improve the performance and protect against severe damage from the vast majority of even tornadoes because, as I've said before, the damage is caused by marginal wind speeds. But we adopted the idea or the philosophy of providing occupant protection in a small room, now called a safe room, because it's very affordable to harden and stiffen a small room of the house to provide near absolute occupant protection. That might be a closet, a pantry, a bathroom, and that's practical for new construction, but the vast majority of safe rooms being installed today are manufactured. They're steel boxes, concrete boxes, timber boxes, installed in the garage, on the slab of the garage, and they're very affordable. There are even those shelters that are mounted under the slab. You can go in the garage, cut out a section of the piece of the garage floor, excavate, put a shelter under there, and put a sliding door on it, so you provide protection without even losing a parking space. There are many, many options available today, and I would say for almost every situation, circumstance, it's possible to design occupant protection from the worst case tornado. And we have a real problem with that right now with public perception, because there was so much bad publicity, misinformation in Oklahoma about having to be underground to survive an EF5. That is simply a falsehood that should be squelched. But in answer to your question, I think there is a way to protect life in a safe room very inexpensively, and I think we must do the best we can in reducing the damage by improving the buildings through building codes enforcement. One other point that I would make that's different in the automobile industry and in the home building industry, both are sensitive to initial cost, but most of the houses are built speculative today. And as you well know, the marketability of housing is very, very sensitive to the initial cost. And not only builders, but I think homeowners too, look at that initial cost and tend to resist any improvement that costs very much initially.
Thank you very much. At this point, I'd like to thank the witnesses for their testimony and the members for their questions. The members of the committee may have additional questions for you, and we will ask that you respond to those in writing. The record will remain open for 2 weeks for additional comments and written questions from the members. At this point, the witnesses are excused. The hearing is adjourned.